and how complex numbers are being used in AC circuits. Okay, so applications of complex numbers are a question of using a real time for 0 degree or positive j for 90 degrees and negative j for negative 90 degrees. So this is to denote the phase angles. Okay, so we have here two circuits with the first circuit. Okay, we have resistor, we have a series resistance and a series uh coil, okay, or inductance. All right. Now,
Sir, are you sharing your screen?
ay hindi pa.
Okay.
Oo. I'm sorry about that. Okay, so can you see my screen now?
Yes.
Okay. Sorry about that. Okay. Okay. So we have a series resistance here and a series inductance here. So this is um for the impedance, okay, for the impedance which we have 3 plus j 4 ohms. Okay, again, this is the Z stands for the impedance, R for resistance, and XL for inductive reactance. Okay, so for impedance B, okay, so we have 3 minus J4, but when we say 3 minus J4, we have a resistance which has 3 ohms and a capacitive reactance of 4 ohms, okay, or negative J 4 ohms. So remember this one, ano? So kapag ka XL, okay, so we will now have an inductance. The sign in between is plus. Okay? The sign in between the impedance is plus. So while if we will have a circuit with a series resistance and a series capacitance, okay, or this is the capacitive reactance, mapapansin nyo na yung ating impedance Z sub B will have 3 minus J4. And then when you plot this, okay, when you analyze this using graphical analysis, okay, yung ating Z sub A, okay, ating Z sub A, so this is our J, okay, and this is our R, okay, which is our resistance. So we have 3 plus J4, 3 plus J4 impedance. So that means we have 3 units, okay, to the right, okay, and then 4 units up. Okay, so 1, 2, 3, 4. Okay, so 3 and 4 nandito siya, di ba? So we have 3. Okay, ito yung ating R, ito yung kanyang head, okay, ito yung kanyang tail. Okay, okay, ganyan, ano. This is the head and this is the tail, and then the J4, apat. Okay, 1, 2, 3, 4. Okay, 1, 2, 3, 4. So that is now the tail, okay, with the head of 3, and then ito na yung head naman ng J4. And then when we draw a line, okay, from the head of J4 to the tail of 3, then this will now result in our impedance A, which is equal to 3 plus J4. Okay? So while Z sub B, okay, or impedance B, when we plot this one, okay, so we have 3 minus J4. Again, di ba, yung ating horizontal axis is our R, and then this is our J, yung ating vertical axis. Okay, so that means we will now have 3 units, okay, of R. So, drawing ka ngayon ng arrow going to the right. Okay. So, this is now the tail, and the head finishes at 3 units. And then, dahil ito ay minus J4, since the upper part is positive J and the lower part is negative J, so therefore, meron kang 4 na units, okay, below. Okay, so that is 1, 2, 3, 4. And then you draw the arrow, okay, joining the tail of the negative J, J4 arrow with the head of 3. Okay, and then you to draw now this hypotenuse, okay, this hypotenuse which corresponds to your impedance Z, which is equal to 3 minus J4. Malinaw ba 'yon? Okay. Is it clear? Yes. Question? Sino yung nagsalita? Any question?
Sir.
Yes. Hmm. Question. Wala naman? So shall we move? Okay, so an angle of 0 degrees or a real number without any J operator, okay, is used for resistance R. So for instance, 3 ohms of R is stated as 3 ohms. Okay, so kung wala tayong reactance, then ang lilitaw lang is yung ating resistance R. Okay? At an angle of 90 degrees or positive J is used for inductive reactance. Okay? So yun yung sinabi natin kanina, no? So kapag doon ka sa taas ng J, okay, dito sa upper part ng J, so that is now the positive J, and that is used for inductive reactance. So while if you are using the lower J or the negative J, this is used for capacitive reactance. Okay? So this rule always applies to XL whether it is in series or parallel with R. Okay? So the fact that IXL, so IXL stands for the voltage because I is the current multiplied by the resistance, which is ohms. Okay? So ampere multiplied by ohms is voltage. So this represents voltage across an inductance, which always leads the current in the inductance by 90 degrees. Okay? And the positive J is you also use for V sub L. Okay? Or the voltage across the inductor or the on the inductor. Okay. An angle of negative 90 degrees or negative J is used for XC, or this is the capacitive reactance. Okay. And then for instance, we have the 4 ohms 4 ohms capacitive reactance, and that denotes that and that is written as negative J4 ohms. Okay. And this rule always applies to XC whether it is in series or in parallel with R. Okay? So you have to remember this always para hindi kayo nagkakamali kung ano yung sign in between ng R at saka ng reactance. Okay? Next. So the reason is that IXC, so IXC is the voltage across the capacitor. Again, this is the I stands for current, and then XC is for the reactance, which is measured in ohms. So ampere multiplied by ohms equals voltage. Okay? So by simple Ohm's law, which always lags the capacitor's charge and discharge current by negative 90 degrees. Okay? And negative J is also used for V sub C. Okay? So with reactive branch currents, the sign for J is reversed compared with reactive ohms. Okay? And because of the opposite, this is because of the opposite angle. Now, how about this one? So how complex? This is a continuation. So this will now be a resistance in parallel with either a an inductor or a capacitor. Okay. So this is now in terms of current. Okay, kanina ang pinag-uusapan natin ay voltage. Okay? Dito ang pinag-uusapan natin kanina voltage. Ngayon dito pag-uusapan naman natin ay current. Now, look at this one. So if we are talking about current, it is no longer the resistance and the XL is no longer connected in series, but rather they are connected in parallel. Okay, and the current flowing here would be your IR, and then the current flowing in your inductor is your I sub L. Okay, and therefore the total current now would be 2 minus J5. Okay, while if we talk about capacitive reactance, okay, so the current now would be 2 plus J5 amperes. Okay, and that we have an IR here of 2 ohms, and for the capacitive reactance or IC, okay, so the current flowing through the capacitor would be positive J5. Okay, so you have to get the difference between the series one and the parallel one. So when we talk about series, okay, when we talk about series or if the circuit is in series, then we are talking about voltage, okay. But if the two components are connected in parallel, then we are now talking about current, okay. And look at the changes in the sign. Okay? So kanina in parallel, in series or in voltage. So when we use XL or when we use an inductor, okay, so the sign in between them is positive. While if uh, for the reactive or for the capacitive reactance, okay, the sign is negative, di ba? So that is because the current, okay, uh, because that is the effect of the lagging, okay, and leading of current, okay, of current and voltage or voltage, okay, because it is all as a general rule, okay, as a general rule, the voltage and the current are always out of phase by 90 degrees. So kaya malamang na if the voltage is already at 90 degrees, okay? So the current, okay, the current is at the zero pa. Okay? So magkaiba yung waveform ng this is the voltage, okay? So depende sa circuit. So naka 90 na yung voltage, tsaka pa lang ngayon lilitaw yung current. Okay? Tsaka pa lang lilitaw yung current. Kaya they are out of phase by 90 degrees. Okay? So this is now the current. Okay? That is the general rule for the voltage and current. They are always out of phase by 90 degrees. Okay. Now, impedance in complex form. The rectangular form of complex numbers is a convenient way to state the impedance of a series resistance and reactance. So the impedance Z plus J4, okay, ito, the impedance is the impedance 3 plus J4, okay, because Z is the phasor sum of 3 ohms of R in series with a J4 ohms of XL. So this is similar with the 3 minus J4 wherein we have a series resistance of 3 ohms with a negative J4 of capacitive reactance. Okay? So the minus sign in Z sub B results from adding the negative term for negative J, that is 3 plus negative J4. Okay? So kaya naging negative J4 siya. And also when we do the graphical analysis, okay? Talaga naman yung upper part ng yung upper part ng ating J, okay? J line or imaginary line is positive and the lower part is negative J. Okay? So these are examples. So for example, we have 4 kilo ohms of R and 2 kilo ohms of XL. Then the impedance will be written as Z sub T is equal to 4,000. That is for the 4 kilo ohms R plus, okay, plus J2000 for the 2 kilo ohm XL, and that is measured in ohms. So isa na lang yung, okay, isa na lang yung unit of measure, yung ohms. Okay? Because this is one whole term. Okay, one whole term of impedance, meaning this is your R and this is your XL. Okay? R and XL are measured in ohms, kaya iisa lang yung ating symbol na ginagamit doon sa dulo, which is ohms. Okay? So similarly, if we have 3 kilo ohms of R and 9 kilo ohms of XC, then the total impedance Z sub T is equal to 3,000 for the 3 kilo ohms R. And since this is XC and they are connected in series, so therefore it would be negative, okay? Negative J 9,000 for the 9 kilo ohms XC. And then we now affix the symbol for resistance, which is the ohm. Okay? Is it clear? And this is how you write when you have 0R. So that is 0 plus J7. Okay? And this is how you write for Z sub T, which is your reactance is equal to 0. So that is 12 plus 12 plus JO. Okay? J sub 0. Okay? So this this is either XL or XC. So the sign in between will depend if it is a if the circuit is inductive or the circuit is capacitive. Okay. So this is the total impedance formula for the series impedances. Okay, it is similar to Ohm's law, wherein the series or the resistances connected in series are only added. Okay. So we have the total impedance Z sub T is equal to Z sub 1, okay, or impedance 1 plus Z sub 2 plus Z sub 3 plus and so on. Okay. And for parallel impedance, same with how we compute for the total resistance in this circuit, di ba? So this is the inverse. Okay? So that is 1 over Z sub T is equal to 1 over Z sub 1 plus 1 over Z sub 2 plus 1 over Z sub 3. Or, di ba? That is equal to Z sub T is equal to 1. Yeah? All over. Okay? 1 over Z sub 1 plus 1 over Z sub 2 plus Z sub 3 plus dot plus Z sub n. Okay? And also, if we have only two parallel impedances, then we could make use of the product over sum method. Okay? So for example, we have this. So we have the circuit 24-7-A, 24-7-A. first circuit, is a series combination of resistances and reactances. So we combine the real terms and J terms separately to compute for the total, okay, for the total impedance. Okay, so how do we do that? Sabi, we combine the real terms. Okay, so we have 9 and 3, so we have 12. Okay, so depende to, no, kung plus or minus tong lalabas. So, pero mapapansin naman natin that J6 and J7 is J6 is greater than J2. So therefore, so pwede natin siyang sabihin na, okay, ito ay equal to J6 minus J2. So it is J4, and what is the symbol in between, for our R and our J would be plus. Okay, dahil mas malaki yung J6 sa J2. Okay? So therefore, your total impedance now would be equal to 12 plus J4. Okay? So ayun siya. Is it clear? Is it clear? Okay. So we have parallel circuits. Okay. So to determine the total impedance, we could determine it by using the inverse formula. So that is 1 over z sub t is equal to 1/4. So ito yun, ano? Ito yung R natin. And then 1 plus J8, this one. And 1 plus negative J5. Okay? So that will be the total Z is equal to 1 all over 1 over 4 plus 1 over J8. Okay? So that is plus, okay, 1 over negative J5. So that means this is 1 all over 1 over 4 plus 1 all over J8 minus 1 over J5. And to, okay, to simplify this, use the concepts in what we have discussed last week. Okay? Paano mag-divide ng complex number? Paano mag-multiply ng complex number? Paano mag-add and subtract ng complex number? Okay? So, follow that. Okay? So this is how you do the operations with complex numbers for addition and subtraction. Again, for addition, we combine the like terms. Okay? So we have 9 and 3, so that is 12, and then J and J2, so that is positive, and that will be J7. Okay? So in here, in next example, we combine this, then we combine this. Okay? So that is 9 plus 3 plus J5 minus J2. Okay? So 9 and 3 is 12, and J5 minus J2 is 3. Okay? And that is the same with the third term. Okay? So to multiply a J term by a real number, then you can make use of the FOIL method as what we do in the FOIL method, in the multiplication of binomials. Okay? So pwede yun, ano? So ganun talaga yung proseso. You have to distribute. Okay? So halimbawa, ito, no? So we have 4 times J3, that is J12, J5 times J6, that's J3, J30, J5 times negative 6 is negative J30, and negative J5 multiplied by positive 6 is still negative J30. And negative J5 multiplied by negative 6 will be positive J30. Okay, and so on. Yes. Any question? Question? Ah,
Wala po, sir.
wala na. Teka lang, kuha lang ito. Okay. So next. So to multiply or divide a real number by a real number. So just multiply or divide the real numbers as in arithmetic. So walang problema. There is no J operation. There is no J operation. The answer is still a real number. Wala kang J. Okay? But to multiply a J term by a J term. So you must remember again, di ba? So pagka nag-multiply ka ng J and J, magkakaroon ka ng J squared. And J squared is always equal to negative 1. Okay? And it will have an effect on the total result. Okay? So to divide a J term by a J term, so divide the J coefficients to produce a real number. Okay? So the J factors cancel. For instance, di ba? J12 divided by J4. So ito na lang 12 at yung 4 ang i-divide natin, and then the J cancels out. And it will become only 3. Okay, the value 3. Okay. Also, we have J30 divided by J5. Again, 30 divided by 5 is 6. And then cancel out the J's. Okay? And that will also be similar to J15 divided by J3. So 15 divided by 3 is 5, and then you cancel out J. So that is how you divide a J term by a J term. So how about you multiply a complex number? Okay. So again, multiplying complex numbers is the same or similar with multiplying binomials. Okay? So you make use of the FOIL pattern. So we have 9 and 3, and then 9 and J2, and then we have J and 5, J5 and 3, and then J5 and minus J2. Again, when you multiply this, you will result in a J square. Okay? Then you always remember that J square is equal to negative 1. Okay? Is it clear? Anyone?
Yes, sir.
Okay. So next, so to divide the complex numbers, okay, to divide complex numbers, the process becomes more involved because divisions of real number by an imaginary number is not possible. Okay, so what do? So impossible. So therefore, the denominator must first be converted to a real number without any J term. And how do you convert that without any J term? So we convert the denominator to a real number without any J term is called rationalization of the fraction. Okay? So to do this, we multiply both the numerator and denominator again by the conjugate. Okay? By the conjugate of the denominator. Ito yung ginawa natin before. Di ba? Na kina-conjugate natin yung complex number. So that the resulting denominator will be a real number. Okay? So what is again the conjugate for? So for example, we have 1 plus J2, the conjugate would be 1 minus J2. So ito lang sign in between ang nagbabago when we conjugate the denominator. Okay? So this is how we do it. Okay, so for example, we have 4 minus J1 divided by 1 plus J2. Okay? So we take the conjugate of 1 plus J2, which is equal to 1 minus J2. So we multiply the original equation. Okay? We multiply the original equation by the conjugate of the denominator, which is 1 minus J2. Okay? So when we multiply the numerator, when we multiply all the values in the numerator, you will get 4 minus J8 minus J1 plus J squared 2. Okay? And if you multiply now the denominators, okay, that is 1 plus J2 and 1 minus J2, you will end up with 1 minus J2 plus J2 minus J squared R. Okay? So, pansinin nyo na yung J minus J2 at saka plus J2 will give you a zero result. Okay? So whatever is in between, it will now be equal to 0. Okay? And then, so may J pa rito eh. Oo, may J pa dyan. But look at your J. It is J square. And your J square is equal to negative 1. Okay? So that means your denominator now would be equal to 1. Okay? So we have negative, okay? So we, sabihin natin this is plus muna, no? Okay? So we will now have negative, negative 1, okay? Negative 1 dahil yung J square natin ay negative 1 multiplied by 4. Okay? Okay? Actually, this is the minus na pala to, sorry, dahil minus yun. So this is minus, okay? So that means now that 1 minus, okay, 1 multiplied by, negative 1 multiplied by 4 is negative 4, okay? So that will now be equal to 1 plus, because minus minus plus will become plus. That will now be become plus 4. So makikita nyo, yung denominator natin ay real number na. It's no longer a complex number. Okay? So pwede mo na ngayon siyang ipang-divide. Okay? So how do you divide this? That is 2 over 5 minus 9 over 5. And then you put on the J. Okay? So 2 over 5. So how much is 2 over 5? Okay? So that is 0.4, 0.4. Okay? And this is 20. That is 4 over 5. Any question? Question? Wala.
Wala po, sir.
Okay. So we continue. Okay, so to divide complex numbers, note that the product of complex number and its conjugate always equals the sum of the squares of the numbers in each term. So this is the same as your special products in binomials. Okay? So that is how you divide complex numbers. Okay, and this is how you plot it. Okay, this is how you plot the impedance Z. Okay, so we have the magnitude and then we also have the phase angle of 37 degrees. So, okay, pagka isinulat natin ito ng, or pagka pinakita natin siya ng ganito, okay, this form is a rectangular form. But when we show it, okay, using these circles, okay, our impedance now is in polar form. Okay, so you have to study your calculators. Hindi ko kabisado na kasi yung mga calculators ngayon, dahil iba na yung ginagamit ko, and you have different models of calculators. So you have to learn in your calculators how to convert rectangular to polar and polar to rectangular, vice versa. So you have to learn it in your calculator, or else ito gagamitin nyo. Itong mga equations na to. This is how you convert a rectangular form of complex number to polar form. And this is how you convert a polar form to rectangular form. Okay? So, mag-IGM lang kayo, no? Mag-IGM. Sorry, IMG pala. Sorry, IMG. Mag-IMG lang kayo about your calculators para malaman nyo kung paano mag-convert ng rectangular to polar and vice versa. Okay? So alam niyo IMG? Alam niyo IMG?
Hindi po, sir.
Search mo sa Google, sir.
Search mo sa Google. And okay, that is IMG. Kayo talaga parang hindi nyo napapagdaanan yan sa mga chat-chat nyo.
Hindi, sir eh.
Hindi pa napagdaanan. So ngayon alam niya na. So pwede nyo nang isagot yan sa mga chat-chat nyo, IMG. Pagka hindi nyo pare-parehas lang. IMG. Yung ETC, alam nyo ba ibig sabihin nun? ETC. Alam niyo ibig sabihin nito? Madalas, 'di ba, madalas ito nakikita sa mga sa tawag dito, sa mga statements.
Sir, et cetera po.
Ayun, etc. So, one meaning of ETC is etc. Okay? So the other meaning of ETC, okay, lalo-lalo na pagka nagsasagot ka ng multiple choice, okay, or any exam, nilalagay mo na lang, pwede mong ilagay yung ETC. Okay? So, ano kaya ibig sabihin ng ETC now stands for, dahil wala ka nang maisip na ilalagay or isasagot. ETC now is end of thinking capacity. Wala ka nang malagay wala ka nang maisip. So that is lagay mo na ETC. So that is end of thinking capacity. Okay? Pero wag nyo gagamitin yan sa akin Altok ko kayo. Okay. So in electrical terms or complex impedance, okay, the 4 plus J3, okay, the 4 plus J3 means you have a 4 ohms of resistance and a 3 ohms of inductive reactance. Okay? With a leading phase angle of 90 degrees. Dahil hindi naman nabanggit Okay? Hindi nabanggit dito sa 4 plus J3 kung ano yung phase angle. Okay? So the magnitude of Z, which is the resultant, okay? So that will now be equal to 16 plus 9, the square root of 16 plus 9, or the square root of 25. So that is equal to 5 ohms. And then finding the square root of the sum of the squares is the vector or phasor addition of two terms in the quadrature of 90 degrees out of phase. Okay? So this is tawag dito. This is when we try to find out, okay, what is now the polar what is now the polar equivalent of this rectangular form 4 plus J3. Okay? Okay. So this will now be your magnitude, which is the 5, which is the real number. Okay? And then arctan, nakikita pa ba sa baba? Nakikita nyo pa ito, yung nasa baba? Actually, what is written below is your impedance is equal to the square root of r square plus xl square. Okay? And the phase angle is equal to arctan of xl over r. Okay? And this is how you convert the rectangular form to polar form. Okay, so the result of this will be the result of r square plus xl would be your magnitude. Okay, and then your theta now would be equal to your phase angle. Okay, so kapag nagkaroon tayo ng conversion, okay, wherein halimbawa ito yung 4 plus j3, so when we convert this to polar form, it will give us 5 a magnitude of 5 and a 37 degrees of phase angle. Okay, so that is now the polar form of the rectangular form 4 plus j3. I hope I hope you could study your calculators and look for your yung sign na ganito, yung R T. Tapos tapos sa ibabaw niyan R minsan meron ganito. So R is rectangular to polar, and then ito naman yung vice versa. Wherein yung iba ganito eh. Yeah? Tapos merong naka-shift. I-shift mo naman, nakalagay naman polar to rectangular. Or ang nakalagay RP pa rin siya, pero pabaliktad naman yung yung arrow. Ibig sabihin polar to rectangular. Ito rectangular to polar. Ito naman vice versa, isa lang yung button. Okay? Minsan isa nga lang yung button pero magkaiba naman yung magkaiba yung kulay. O, titingnan niyo na lang doon. Ito RP tapos isa naman PR. Okay. So may mga ganyang calculators, no? I am not familiar with your calculators if you are using this one. Ano nasa calcu nyo? Ngayon, kailangan nyo na talaga ng calcu. Kasi kung hindi kayo magka-calcu, matatagalan kayo. Mahirapan kayo. Ano nakikita nyo sa calcu nyo? Anyone who has calculator at this moment? Anyone? Wala? Walang may hawak na calculator? Okay. So mukhang walang may dalang calculator. So anyway, okay. So pagka naaral nyo na yung calculator nyo, please do this. Okay? Please do this exercises. Tingnan nyo kung itong mga rectangular na to ay makakakuha kayo ng ganitong polar form. Okay? So this is the magnitude and this is the phase angle. Tapos pagka na-discover nyo na itong yung pag-convert ng rectangular to polar, discoverin nyo naman ngayon yung pabaliktad, yung polar to rectangular. Kasi merong mga operations sa ating mga circuits na hindi ka po pwedeng diretso rectangular to rectangular or polar to polar, okay, na operation. So dapat meron kang gagawin diyan, i-convert mo muna yung from rectangular to polar or from polar to rectangular. Okay, before you can do the mathematical operation or the phasor addition. Okay? So magnitude and angle of complex numbers. So ito yung sinasabi ko kanina, no? So there are scientific calculators of keys that can convert from rectangular coordinates to polar coordinates. Okay, you just have to study your calculators. Okay, so this is how you convert polar form of a complex numbers. Again, please practice. Okay, practicein nyo to sa calculators nyo and even this one. Okay, yung pag-convert ng mga may zero. Okay. So multiplication and division in polar form of complex numbers. So before we have already discussed how to multiply and divide complex numbers, and that is in rectangular form. And this is how you do it when you multiply or divide complex numbers in polar form. For multiplication, you multiply the magnitudes and add the angles algebraically. Okay? So you multiply the magnitude, that is 24 times 2. Okay? So 24 times 2. And then you add the angles. So 40 degrees and 70 degrees. So that will now be 24 times 2. That is 48. Okay? And then 40 plus 30 degrees is equal to 70. Okay? And that will all be the same with the others. You multiply the magnitudes, okay? You multiply the magnitudes and then you add the angles. So that is for multiplication. So while for division, okay, similar siya doon sa ating multiplication, but okay, ang gagawin naman natin ngayon is you divide naman the magnitudes. So we'll now have 24 and 2. So 24 divided by 2. And yung naman ating phase angles, okay, we have to subtract. Okay? So that is how you divide, okay, complex numbers in polar form. Okay? Is it clear?
Yes, po.
Okay. So this is an example, ano? You divide 10 by 5. Okay? So since yung 10, we don't have any phase angle, so that will give us 0 degrees. Okay? So 10 over 5 is 2. So we divide the magnitudes, which are 10 and 5. So it gives us 2, and then we subtract the phase angles. Dahil dito sa original natin, we don't have any phase angle. So we could assume that is 0 angle. So that is 0 minus 30 degrees. So that will give us a magnitude of 2 and a negative 30 degrees of phase angle. Okay? Okay? Now to continue, okay? So this is how you convert polar to rectangular form. Okay. Complex numbers in polar form are convenient for multiplication and division, but they cannot be added or subtracted if their angles are different. Okay? So kaya kailangan ibalik mo muna siya sa rectangular form and then you can do the addition and subtraction. Okay? So this is how you convert polar to rectangular form, yung ating long method. Okay? For the R component, you multiply the Z by cosine theta. Okay? And then for the X term or for the imaginary term, you multiply Z impedance by sine theta. Okay? So how do we do that? If we have this, okay, magnitude of 5 and we have 37 degrees as our phase angle. So that is R is equal to so that is equal to 5 multiplied by cosine of 37 degrees. Yeah. Okay, so cosine 37 degrees is 0.8. Okay, so we will now have, okay, so 5 times 0.8, that is 4. And for our x, okay, or for the imaginary part, that is we multiply 5 or our z by sine theta, or that is sine 37 degrees. Okay, so sine 37 degrees is 0.6, and then 0.6 multiplied by 5, which gives us 3. So combining the 4 and 3, so this is x, ito yung 3, and then this is our r. So therefore, we will now have 4 plus j3, j3, positive j3, because the 3 here is positive. Okay, and this is now the equivalent. Okay, this is now the equivalent diagram. Okay, this is now the equivalent diagram of the polar form 5 degree. This is now the diagram for the rectangular form 4 plus J3. So we have 4. We have 4 units. Okay? 1, 2, 3. Sabihin natin 4. 4 units to the right and 3 units up, and then we connect the tail and head, okay, and that will now be your Z, okay, for your total impedance. Okay, is it clear? Okay, so you practice those yung converting polar to rectangular and rectangular to polar. Okay. So let us now talk about the complex numbers in series AC circuits. Okay. For example, we have we have R1 of 2 ohms and an XL of J4 ohms, and another R of 4 ohms, and an XC, equal to negative J12 ohms. Okay, and so what will now be the total? Impedance? Okay? What will now be the total impedance of the circuit? Okay, so what do we do? So the total impedance is the sum of all the impedances. Okay? And then how do we do that? Ito, napakadali nito dahil this is the two impedances are in the two impedances are connected in series and they are in rectangular form. So if they are in rectangular form, then you just combine the real terms and combine the imaginary terms or the J terms. Diba? And to combine that, that is the total impedance now would be equal to 2 plus 4 ohms, and that will now be equal to 6. Okay. And then we have combining J4 and negative J12. So kitang-kita agad natin na mas malaki yung J12 sa J4. Then the difference is J8. And the symbol will now be negative because the negative J12 is much bigger than positive J4. Okay? So your total impedance now would be equal to, in rectangular form, would be equal to 6 minus J8, and in polar form, that will now be equal to 10, a magnitude of 10, with a phase angle of negative 50 degrees. Okay? So how do we arrive to this? You just make use of the conversion formula from rectangular to polar. Okay? Is it clear? Nag-usap pa ba ako? Okay. Okay. So how about ZT in polar? Right? In polar form. Okay? So we could convert ZT from rectangular to polar form. So ginawa na natin yun. Okay? So by using these formula. Okay? Wherein yung ating magnitude is equal to the square of R and the square of XC or XL. Okay? That will now be your component R. You take and then you take the square root. Okay? And then for the phase angle, you take the arctangent of the relation between negative J8 and 6. So that is negative 8 over 6. And it will give you arctan of 1.33, and arctan of 1.33 is equal to negative 53 degrees. Okay? So sa calculator, simpleng-simple yan. Kaya pag-aralan.
Sir, divide po ba yun?
Alin?
Yung 10 tas negative 53 degrees ohms.
Hindi.
Divide.
Hindi, ito, symbol
Opo,
na to.
opo, opo.
No, this is how you draw the phase angle.
Okay po, sir.
Okay. So, ganyan siya. Hindi siya divide. So, slanted siya. That separates the magnitude from the phase angle. Okay? Question? None? Okay, so let's move. And this is how you calculate I. Again, to calculate I, you just follow Ohm's law. Okay, so current is also current or the total current now would be equal to the total voltage divided by the total impedance Z. Okay? So 'di ba sa DC analysis sa circuits 1 natin ganun din, 'di ba? I is equal to V over R. Diba? Yung Z sub T, yun din yung R because Z sub T is measured in ohms. R is measured also in ohms. So we could make use of Ohm's law. Okay? So we have already determined, okay? So we have already determined the total impedance a while ago. And then binigyan tayo ng total voltage, that the total voltage is equal to magnitude of 20 with phase angle of 0. Okay? So the next thing we have to do is we divide. Okay? We divide 20 by 10 over negative. Ito 0. 0 degrees. Okay? So 20 divided by 10 is 2. Okay? And then, di ba, pagka division daw, magma-minus tayo ng angle. So that will now be equal to, so that is 20 over 10. And then the phase angle would be equal to 0 degrees minus 53 degrees. So minus minus, that will now be plus. So therefore, okay, so this will now be 20 over 10 is 2 with a phase angle of 0 minus minus, so that will now be the positive. That is, your current now would have a magnitude of 2, okay, and a phase angle of 53 degrees amperes. Okay, dahil current eh. Yeah, current pinag-usapan natin. So therefore, that will now be equal to amperes. Okay? So, these formulas, okay, this is how you determine the voltage across R. So we have VR1. Again, this is Ohm's law, no? So we have I multiplied by R1 kasi yung I natin, eto na. Nakuha na natin. And then this is now how you compute for the voltage across the inductor. So that is VL is equal to IL multiplied by XL. Okay? And this is how you, okay? And this is how you determine now the voltage drop, okay, across the resistance R2. So that is IR2. Okay? And this is how you determine now the voltage across the capacitor, which is equal to I multiplied by C. Okay? Is it clear? Okay, so silence
Yes po,
me.
sir.
Okay. So this is now the this is how what we are talking about the phase angle of the circuit. Okay? And then to find each voltage, yun nga, no, gamit na lang tayo ng Ohm's law. Dahil alam na natin yung dumadaloy na circuit doon sa body. Okay? Or doon sa circuit. Okay? So this is the phase angle of each voltage. This is how we discuss the phase angle of the voltage. And also the phase angle of the current will also be similar to that. So total voltage equals the phasor sum of the series voltage drops. So again, pagka sinabing phasor sum, dapat mayroong magnitude at mayroong phase angle. Okay? So merong real part at merong imaginary part. Okay? So that will now be your total voltage. Okay? Any questions so far?
Wala po, sir.
Okay. So this is now how you apply complex numbers in parallel AC circuits. Now to find the total impedance, again, we make use of the product over sum method. Okay. So the total impedance now would be equal to 10 times J10. 10 plus then the numerator to multiply, di ba? So this is how we multiply complex numbers, make use of the FOIL method, and to add the denominator, we have to combine the real term and combine the imaginary. So complex numbers in AC circuits. Okay. So this is how you convert. Na? So convert mo muna yung kasi dapat dito. Convert mo muna into polar form para mas mabilis. Kasi di ba in division of polar form, complex numbers in polar form, you divide the magnitudes and then you subtract the phase angles. So 100 divided by 14.4, that is 7.07. And 90 minus 45 is 45. Okay? So that will now be your total impedance in polar form. Okay? And this impedance in polar form is also equivalent to the impedance in rectangular form, which is equal to 5 plus J. Okay? Alin ang wala? Hello? Hello? Hello?
Sir,
Okay.
yung question po ata kanina, sir, wala po.
Okay. So, sorry. Kala ko hindi nawala yung audio ko. How about combining two complex branch currents? Okay. So, ito naman talagang buong impedance na to, Z1 and Z2. Okay? This whole one is Z sub 1 and this, or impedance 1, and this whole is your impedance 2. Okay? So, this is a common application in circuit with two branches. We have Z sub 1 and Z sub 2. So, where each is a complex impedance. With both reactance and resistance. So a circuit such as that in this figure can be solved only graphically or by complex numbers. So actually, using the complex numbers is the shortest method. Kesa nga naman i-analyze mo siya in graphical method, magdo-drawing ka pa. Okay? So the procedure here is to find the total impedance as the product divided by the sum of Z sub 1 and Z sub 2. Okay? So, looking at Z sub 1, they are connected in series. So, therefore, we could write this as 6 plus J8. Okay? Ito siya, 6 plus J8. And then, looking at Z sub 2, the R and the capacitive reactance is connected also in series. So, therefore, we could write this Z sub 2 as 4 minus J4. Okay? Ito na ngayon yung ating Z sub 2. So 4 minus J4. And this is the converted rectangular form to polar form. Okay? So 6 plus J8 in rectangular form is equal to magnitude 10 and phase angle of 53 degrees in polar form. Similarly, with Z sub 2, we have 4 minus J4 in rectangular form. And the equivalent of the 4 minus J4 in polar form is magnitude 5 5.66 with the phase angle of negative 45 degrees. Okay? So, if we have two impedances in series or in parallel, sorry, we could determine the total impedance by using the product over sum method. Okay? So, madali ito, no? Kung product ito, mas madaling gawin. Yeah? Dahil kung product 'yan, we can make use of the polar form. Okay? And z sub 2 naman, or the denominator can be analyzed using the rectangular form. So kaya sinulat natin ito ngayon na ito yung z sub 1, yung z sub 1 multiplied by z sub 2. Di ba kanina yung ating formula is total impedance is z sub 1 multiplied by z sub 2 divided by z sub 1 plus z sub 2. So this is the product over sum method. So z sub 1 is magnitude 10, 53 degrees phase angle, and then z sub 2 converted to polar is 5.66 magnitude and negative 45 degrees of phase angle. Okay? So yung denominator naman, gagawin natin na we have 6 plus J8 and then we have 4 minus J4. So plus. Okay? Yan yung standard form. So we can do now direct. Okay? So we multiply 10 and 5.66, we get 56.6, and then we add 53 degrees and negative 48 degrees. So that will give us negative, 8 degrees phase angle positive. And then combining 6 and 4, we have 10, and then J8 and minus J4 would be plus J4. Okay. Pero hindi pa rito natatapos to. Okay? We convert now the denominator 10 plus J4 into polar form kasi mas madali nga mas madali tayo mag-compute, okay? If both are in polar form kasi i-divide lang naman natin yung mga magnitudes and then we subtract the phase angle. So converting the 10 plus J4 into polar form, we get 10.8 magnitude with 22 degrees phase angle. Okay, so copying the numerator, which is 56.8 with 8 degrees, okay, with 8 degrees phase angle, and then the converted 10 plus J4 is equal to 10.8 magnitude and 22 degrees phase angle. Again, we divide this, okay, and then we subtract this one. So dividing 56.6 by 10.8, so we have 5.24, and then subtracting 8 and 22 degrees, so we will now have negative 14 degrees. Okay? So the total impedance now would be equal to magnitude of 5.24. Okay? Magnitude of 5.24 with a phase angle of negative 14 degrees. Okay? Or you could convert this to rectangular form, which is something about 5.08 minus, this is J 1.27. Okay? and measured in ohms. Okay? Can still follow? Can still follow?
Yes po, sir.
Okay? So, ito no? Ito yung kanina. Ito na yung rectangular form. 5.08 minus J1.27. Okay? So, that is now the total impedance of the two complex branch impedances. So, how about taking the total current of two branches, okay? Of two branch or combining complex branch currents, okay? So again, we have branch 1 of R1 and XC, and then branch 2 of R2 and XL. So for example, no, we have I1 of 6 plus J6 and then I2 of I2 of 3 minus J4. Ito, so given yung ating I1 and I2. Again, so since the two quantities are both in rectangular form, okay, we could simply just add yung real terms and combine with and then combine the imaginary terms, okay, or the J terms. So that is 6 plus 3, which gives us 9, and J6 minus J4 is equal to J2 amperes. Okay, dahil current yung ating pinag-uusapan. Okay. Okay, and then this is now the equivalent of our current in polar form. So converting converting the current, which is 9 plus J2, okay, the total current of 9 plus J2, we could now convert that in polar form. So it will now give us 9.22 of magnitude and the phase angle of 12.53 amperes. Okay. So kahit naman dito sa ating rectangular form, it is 9 plus J2 amperes. Okay? Is it clear? Okay? So this is how you how to combine naman parallel circuit with three complex branches. Okay? Okay? So to do this, these are the following steps. You convert each branch branch impedance to polar form. So this is necessary for dividing into the applied voltage VA. Okay? And then to calculate the individual branch currents. So if VA is not given, then any convenient value can be assumed. Okay? But noting that VA has a phase angle of 0 degrees. Okay? Because it is the reference. And then next, you convert the individual branch currents from polar to rectangular form so that they can be added for the total line current. So madali lang. Okay? You combine the real terms, and you combine the J terms. And this step is necessary because the resistive and reactive component must be added separately. Okay, so next step, you convert the total line current from rectangular to polar form for dividing into the applied voltage to calculate Z sub P, or the total impedance. Kasi the total impedance will have a ratio between the voltage and the current. So division yung mathematical operation in between. So it is best that the two values are in polar form. So para mas madali ang operation. Okay? And the fourth step would be the total impedance can remain in polar form with its magnitude and phase angle, or can be converted to rectangular form for its resistive and reactive components. Okay? So depende na yan. Any of the two will apply. Okay? So these steps are used in the following calculations to solve the circuit in, so this circuit, yeah. Z sub 1, Z sub 2, and Z sub 3. So again, each Z is converted from rectangular form. So we have 50 minus J50. So that is converted to polar form. That is 70.7 with a phase angle of negative 45 degrees. And impedance 2, the 40 plus J30 is equivalent to 50 magnitude and phase angle of 37 degrees. And finally, our impedance 3, the 30 plus J40, okay, is equal to the polar form 50 with magnitude 50 with the phase angle of 53 degrees. Okay. So, to get the current, so we have VA over Z sub 1. So, tingnan nga natin yung ating circuit. So, we have ZA, which is 100 volts. So, 100 volts lang to, no? So, wala tayong phase angle, kaya that is 0 degrees. Okay? So, since this is parallel, all the voltage across this are equal to 100. Okay? So, therefore, okay, our V is equal to 100, magnitude 100, 0 degrees, phase angle. This is now the converted in rectangular form. Okay, so we have magnitude of 70.7 and a phase angle of negative 45 degrees. So, di ba? We divide this, okay, and then we subtract this one. So that is 0 minus 45, that is now positive 45 degrees. And 100 divided by 70.7 is equal to 1.414. Okay? So this is now the current, or for the branch current I1, okay, in polar form, and this is now the branch current I1 in rectangular form. Okay? So similarly for I2, to get I2 or the branch current I2, okay, we divide the voltage by the impedance Z sub 2. Okay? Again, yeah, yung circuit natin ay parallel with a voltage of 0, with a voltage of 100 volts and 0 phase angle. Okay? Mapapansin nyo to, dalawa to, negative JXC at saka positive JXL. Okay? So, pwede natin i-combine to, negative 70 plus 110, that will now be positive, yeah, positive J40. Okay? Kaya dito, okay, ito na siya, J40 na siya. Kasi kinombine natin itong dalawa. dalawang reactances, the capacitive and the inductive reactances. Para maging ganito na lang siya. Okay? So, and that is how you compute for the branch currents. And to determine now the total current, you simply add the currents. So we have 1 plus I1 plus I2 plus I3. So, dahil kinonvert na natin itong mga to, okay, kinonvert na rin naman natin ito to rectangular form, then pagka kinuha natin yung total, then we could just combine all the real terms we could just combine the real terms and the J terms. That is 1, 1.2, and 1.6. Okay? 1, 1.6, and 1.2. So that is 3.2. So that is 3.8. And J1 minus J1.2 minus J1.6 is negative J1.8. Okay? In rectangular form. And this will now be in polar form. Okay? So this is how you get the total impedance in polar form. Okay, VA is 100 with 0 degrees, and the total current, the converted total current from rectangular form to polar form is 4.2 with a negative 25.4 phase angle. So we divide 100 by 4.2, therefore we have a magnitude of 23.8, and subtracting 0 and negative 25.4, so that will now be positive 25.4. Okay, so the total impedance now in polar form would be equal to 23.8 magnitude with a phase angle of 25.4, and this will now be the converted total impedance in rectangular form. Okay, so any question about this? Question so far? Anyone?
Wala naman.
Okay. Okay. And that will be all for tonight. Okay. So please study Please study yung ating mga pinag-aral-aralan ngayon. And now I will try to get your attendance. Okay. Elizabeth,
Present po.
parang ngayon ka lang pumasok?
Yes po, sir. Late enrolled po.
Late enrolled. Okay.
Opo.
Pero wala ka sa akin sa circuits 1.
Opo. CPE po ako.
Okay.
Yes
Hindi ka umubra doon sa isang schedule ng CPE.
Hindi po.
Kasi meron pa
Opo.
isa pa circuits 2 sa ng CPE. So anyway.
Thank you po.
Okay. kay Sir Felix Dolot. Okay. Anyway. So, next, Crizel,
Present po.
Carlos,
Present po, sir.
Patrick,
Present po, sir.
Adrian,
Present po, sir.
Clint,
Present po, sir.
Ramil,
Present po.
John Maury,
Present po, sir.
Eduardo Gutierrez, Rob Limbo,
Present po, sir.
Bernard,
Present, sir. Present.
Brennan, wala. Michael Natividad,
Present po, sir.
John Micah,
Present po, sir.
Leonard, wala si Leonard. Rina,
Present, sir.
Stephanie,
Present po.
Mike, nagpaalam to, wala rin sa internet. Oliver, sino yung nag-chat? Hindi ko narinig, Rob, yung ano mo eh. Present mo eh. Saan ka na ba? Yung narinig ko pala. And then, Oliver, nandyan? Wala. Russell. Okay. So, that will be all for tonight. And then, expect na yung ating lecture will be provided in our campus. Okay? So, we'll see each other
Sir,
on
by the way, kailan po
Yes.
submission nung lab 2?
Lab 2 was to be submitted last Thursday. Hindi ko pala na-i-activate yung submission. Sorry. Anyway, tawag dito, submit na lang Wednesday. Okay?
Okay, sir. Thank you po.
And then on Wednesday, you do experiment lab activity 3. Okay?
Okay po.
Okay. So that will be all for tonight, guys. Thank you. Have a great night.
Okay po, sir.
Bye.